streams, this is the concept you all must have studied in your school level, the water cycle, where the water from the ocean which evaporates and it forms clouds, it precipitates, and the precipitation, some part of it is converting into ice and forms a part of glacier. Some part of it started flowing through the surface as a process, and it is surface runoff, and it reaches the sea, and some part of that which will be absorbed by the soil which infiltrate and it moves as a groundwater, and some part of it which will be used by plants or plants, and that will be transpiration process from the plants and it reaches the atmosphere back. So this is a complete cyclic process of water which is on the surface of the earth. So if you see a stream or a river, it originates from a hilly terrain, okay, and it flows through the different landforms, and finally it reaches the sea. This is the total life of a river. And if you see the longitudinal profile of this river, this we can divide basically into three parts. The first part we call it as the head region, the second part we call it as the middle region, and the third part we call it as the mouth. So the activity of river in this all three different parts are different. Like if you see it in the head region where the slope is high, very high, and the flow of water, the velocity of water, the activities of water, the energy of the water will be very high in the highland region or the head region. So in that region, the river is more dynamic. It is capable to carry large amount of loads, large amount of sediments. It can be able to erode and it can able to transport to the foothill or the base of the valley. So in this part we call it as the head region, or we call this region where the river activity is in youth stage, that it is very dynamic stage of the river. Okay, so it reaches up to some part in the middle of the river. Middle of the river, when it reaches, where what happens, the river reduces its capacity. Here in this part the slope is very high, river is capable to carry large sediments, but when it reaches into some part, when we crosses at some slope level, then the slope of the river gradually decreases. So here the slope was very high, but when you come here the slope is reduces, and as a result the slope reduces, the river will not be able to carry all this high amount of load which is carrying from this part. As a result, it will start depositing the sediments here, and it will also take some meandering channels. Meandering channels means it is nothing but it is the channel which is flowing through this curve nature. Because of the change in the slope, the river is not able to flow or carry the load, so it actually takes a curved path, and in that stage we consider the river is in the mature stage. Okay, so in the youth stage, the river is capable to do a lot of work. It is highly energetic, highly dynamic, but in the case of mature stage, the river is not capable to carry all this high amount of load. Rather, it will be selectively transporting the material, and in this stage the erosion activity will be very high. And in this stage, in the case of middle stage, where the erosion deposition processes would be matching, so there would be almost the same amount of erosion deposition processes. But when it comes to the very end of the river, at this stage we call the river is in the mouth stage, or the river is in its old stage. The old stage because the river in this part is not capable to carry all its load, rather the process of more activities of deposition, because the part will become almost horizontal, and it will be in meeting the sea. So at this part the river is very gently sloping, and the amount of materials which are transporting from the high head region to the middle region, and it is more dominated by the deposition of that material. So this part we call it as the mouth stage, or the old stage of the river. So this is what a river which we are talking about. And if you see the cross section of this river, this is the river in it, the this part at the head region. So if you see the cross section, the river valley, this is the river valley. The river valley is very narrow and it is bounded by hard rocks. Hard rocks means it is highly compact and dense, resistive rocks. Whereas it comes to this region where it is the middle region, or in the intersection of middle or the mouth and the middle region, where the river is flowing in a wider valley. The valley is very wider, and the water is, if we see that um, it is flowing through the valley which is wider in nature. Okay, so this is the area, and this river, if it is flowing in this part, it doesn't mean that it will only flow in this channel throughout the year. There are number of cases that this channel may shift from this part to something like this. So water will be flowing on this channel, or sometime this may flow on this part, sometime it may flow on this part. Or what I'm saying is that the channel which is flowing right now on this channel will have different processes. It may shift the channel anywhere in this part. Some area it will flow on this part, this is one area, and when it comes to other part, it may shift from this part to this part. So this kind of changes in the river are possible in this part of the river. Whereas in the head region, it is mostly flowing through the bedrock, so the chances of shifting of river is a little bit difficult, or it is not that much easy to shift the river. Rather, it will be more eroding and deepening of the valley processes will be active. And here I am talking about some of the terminologies which are associated with a river. A river stream is nothing but which is a surface water flowing in a channel of their own. So there are well defined channels. The river is established a channel, and that is called a streams. Okay, so a river is what? It is a large stream flowing through large area and receiving other streams from sides is called a river. So if you see here, this is a stream, and this streams meet to the one major stream here, and this is another stream, and this is another stream. This streams meets the large river. So this we call it as a river, and these are all the streams. And other than that, during the rainy season, during the raining season, there are number of small channels which may be developing here all, but these are not called still streams, because this is not a permanent feature. This stream which is producing is not a permanent feature. Like if you see here, there may be some streams flowing here, water from here, it may be contributing to this river, but this is still not a fixed channel, so that is not called a stream. A tributary is nothing but a small channel running to a large river. So streams are also called sometimes tributaries, because that particular stream contributes to a major channel. So drainage system is actually the connection of all these streams and rivers. Collectively it called a drainage system. For example, this is one drainage system which includes all this. This is a one single drainage system. Okay, so this is what we call it as a drainage system. That means the water flowing on this part, all this will be contributing to this river. Okay, so this boundary what I have drawn here, this boundary what it indicates, a water which is flowing on this part will be contributing to this river is called the drainage basin. So every river will have a drainage basin, that is a topographically divided portion from where a particular river collects water. Okay, so in this stream, if you see a water which is flowing on this part, it may not be contributing to this river. Rather, it will be flowing through this river. There may be another river flowing here, and that will be contributing to that river. So that river will have another drainage basin. So drainage basin means it is a region from which one particular river collects water. Okay, so that particular boundary or the topographical barrier from which the water collects is called a drainage basin. So to make you little more clear about this drainage basin concept, I am just sharing another screen. Right now, what you are seeing on the screen is our part of the Gujarat. We call it as a mainland Gujarat. And there is one river which is flowing here. This river is called Narmada. And here we have Tapi. This is Sabarmati river. Three rivers, major rivers, and Narmada become one of the major west flowing river in the Gujarat or in India. Correct. If you see the Narmada river, which flows through this part, it is in the Madhya Pradesh, and which comes into the Gujarat alluvial plain. We call it as an alluvial plain. And this is what I was talking about in this part. The river is taking, so in this part, if you see, the river is taking a general topographical flow, and it is flowing through the mature stage. And if you see, these are all the meanders. Okay, so this channel, this is what I was talking about. The river doesn't flow in its mature stage. It doesn't flow in its one path. There are number of areas where it is changing. See this part. If you see here, there is a change in the river. What happens to the river? It shifted from this bank to this bank. Okay, and in this part also, if you see, the river is shifted. Similarly, if you see this part, the river shifted from this part to this part. Northern shifting and southern shifting. So this is actually the process of the river. And if you go to the mouth portion of the river, we can see that the river is now meeting the Cambe, basin Cambe, and here it is the part where it is more depositional, and you will see number of depositional features here. Okay, so this is one thing, and if you are talking about the drainage basin of this river, this is what we are seeing the river right now from a top view. And if you want to see the cross section, that how the height varies, for example, I am going to do is, see, this is the river, okay, and what I am going to make a cross section of this river. And now as I said, I reach the hill. Okay, so you see now how the variation of the river is. Okay, so where I'm going to talk here, this is the region where it is on the floodplain. What is the elevation here? It is almost 0 meters. See, the river is flowing almost 0 meters to 45 meters to then slowly increasing. Then it is going to the highland where it is flowing through the hilly terrains, and the elevation you see now, it is 204 meter, 118 meter. Then it increases 176. It goes up. See, this is how the variation of the height. So the elevation of this river, which is flowing from Madhya Pradesh, is goes from 500 meters to around 0 meter elevation. Okay, so this is what a river. So obviously the river which is flowing on this part, which is basically more erosion feature in nature, but in this part where it comes to the alluvial plain, it will be more depositional in nature. Now what we are going to see is that what geological activities these rivers are doing. So any river which is flowing, which will be doing three main processes. First process is called erosion, second process is called a transportation, and third process is called a deposition. Erosion is nothing but this is a bedrock. Bedrock means it's a rock over which the water flows, and here in the top it is the this is the air. Okay, this is atmosphere, and this is the boundary of water. Okay, and this is the boundary of the rock through which the water flows. So this is a rock rock portion. This is the water column and this is air. So water, when it is flowing through the surface, there are number of small areas where these rocks will be having some fractures or some surface features which will enable this water to weather. Weathering is what? It is actually a detachment of material from the surface of any solid rock. Okay, so this detached material, this process is called weathering. Weathering doesn't remove the material from the surface. Rather, weathering will produce something that will be slightly detached from the surface of the rock. Now, this water which is flowing here, it will put some pressure on this weathered loose material, and that will be picked and that will move from one portion to another portion. Then the process is called erosion. Correct? So this eroded material will be transported by this water in different modes. Either it will roll, if it is very heavy, then it will just roll down. Okay. Sometimes it may be taken into suspension. So this all processes we call it as a transportation. Okay, so this is erosion and this is transportation, and deposition I am not showing here. Deposition is the feature where this transported materials will be deposited somewhere and it will produce some landforms. So that process is called a deposition process. So river do all these processes. What are those three? Erosion, transportation and deposition. Okay, so the geological action of river for a civil engineer, these three processes are important to understand. Where the rivers are eroding, where the rivers are transportation is not very important, but how it is transporting, but where it is depositing, which is the deposition end, which is the erosional end, and which is the transportational features of a river. So that is what we are going to see one by one. First one, let us see the methods of erosion of the river. There are four main processes. One is hydraulic action, second one is abrasion, third one it is called attrition, and fourth one it is called corrosion. These are all simple processes. First one, it is hydraulic action. This picking up of the sediment is by the water. There is no other agent which is involved in picking up this water. So this is what the process we call it as a hydraulic action. So hydraulic action is the mechanism of losing and removal of rock by water. So this is called hydraulic action. So sometimes in the case of waterfalls, we usually see what this is a waterfall, and the waterfall, when the water flows from this height, which mix with the air, and it creates some depressions or the erosions in this part, and this process we call it as a cavitation process. Okay, it's a water and the air combined together which erodes, we call it as a cavitation process, and this is a subpart of the hydraulic action. Then there is a process called abrasion. Abrasion is what? Abrasion is the eroded material. Now there are materials which are eroded by the water. Now this material, this sediment, we call it as a sediment. This sediment which collide with the sediment will produce small pieces of fraction. So this process, water and the sediment together will hit this part and it erodes the material from here. That process is called a abrasion process. One is collision between this, that is one, and this eroded material interacting with this, that is another portion, and this collision of sediment and the water together, when it's erode the material, we call it as a abrasion process. It's nothing but water is having fine grains of some rock particles. So when the water hits the rock surface, along with that there are some grains also hit the rock surface. As a result, the erosion processes will be more and that will be more active. So that process we call it as a abrasion, whereas the breaking up of materials by mutual collision is called a process of attrition. There are two materials, two sediments which are eroded already. Now this sediment, if I move along with the water and hit on this, then these two things will hit together and break into four pieces. So that process is called a attrition process. Okay. So that is attrition, and solution activity, which is nothing but the chemical process. So dissolved materials. And you see water at our home, this water will not have any sediments within that. But if you pass that water through a filter, then we'll see that there are so many materials coming out. So these all things are dissolved materials in the water. So that is a solution activity. So these are the three main processes by which a river do its erosion. Correct? So what are the processes? First is hydraulic action, then abrasion, then attrition, then it is the corrosion. Corrosion is the chemical action and it produces a solution. So it dissolves in the water. So one more thing what we are going to discuss here, it is the rate of these erosion processes will be basically depend on number of parameters. Number one, it is velocity of the stream, and velocity of the stream is also not uniform in all the parts of the streams. For example, this AA is a cross section of this section which is showing at this part, where in this end if you see it is mostly a depositional low energy condition because the river flows in this way and the major energy coming to this end. So this is the part where it produces high velocity, whereas in this part, whereas towards the stream it will be less part. So the point is that when the river flows, there are different areas will have different velocity of stream. So where it is having more velocity, it will erode more. If you remember the first lecture, the introductory lecture, I was talking about the Baruch erosion process. That is this criteria. When there is a more velocity, there would be more erosion. Where there is a less velocity, there would be more deposition. So this is the process it happens. So velocity is one part which controls the erosion nature of the river. Second one, it is the lithology of the rock. If the rock is more stable, hard rocks, then there would be less erosion. But if the rocks are of loose materials, then the sides will be colliding more easily and it can create more wider channels. As a result, the velocity decreases, more deposition will happen. So that kind of dynamic system is there. So lithology of the rock, there are some rocks which are very easy to erode, but there are some rocks which are not easy to erode. So the rocks which are easy to erode will produce more erosion, but whereas the rocks which is resistant to erosion will produce less erosion processes. So velocity is one thing. Velocity is also controlled by the shape of the river. If it is a narrow river, then it will be more faster like this. Here the river is wider, but when it comes to this part, it is more narrow. So this portion will erode more. So similarly, when there is a lithology easy to erode, it will erode easily, but it is a compact resistive rocks will produce less erosion process. And last one, it is the load. Load is that the carrying the materials which is carrying by the river. So if the river is already carrying a lot of materials and it is not having a capacity to erode more, the erosion processes on that river will be less. So depending on the load, if it is not having any load, it is not having suspended load, or it is not having any materials carrying by the river, so it will have more energy to erode, and the processes of erosion will be more in the case of rivers which are less in the load. Okay, so these are the three main processes which controls the erosion. And if we see that all these processes together will produce number of different geological features in a river system. What kind of geological features or the changes a river erosion is doing in the surface of our earth? Okay. So if you see that the processes which are done by the erosion processes, what are the processes? Which includes hydraulic action, abrasion and attrition, three main processes, and chemical action is the next process, corrosion processes. So the hydraulic action and the abrasion processes together at the initial stage of a river, it produces one landform or produces a feature. That feature is called potholes. Potholes means it is the shape of the hole is the depression which is making by the river is something like a pot. I'll tell you that how it is happening. This is a river surface through which the water flows, and the writing here it is a bedrock. Bedrock means it is a solid crystalline or solid hard rock. So the water which is flowing over this hard rock surface, what happened? There would be some kind of surface features or some irregularities on the surface of this rock that will peak by this water. Okay, so as a result, what happened? There is a small depression which formed on the surface. A small depression which formed on the surface. Now this process is mainly done by the water only, so we call it as a hydraulic action. Now what happens after this formation of a small hole? There may be some small grains. Grains means there are the sediments that may enter into this small depression, and water is still again flowing through the surface. As a result of flowing of this water which is getting into a small depression, there would be small circular movements will take place. Initially there is a very small process of a circular movement, and that circular movement will take place, and this will increase the depression. So when it increases the depression means the process now it is water along with the sediments, so that together will increase the depression or the cavity which is formed on the surface. Now again when it increases the depression, then the more amount of sediments will trap into this depression. As a result, what happens? The erosion in the bottom part will larger compared to the neck part. So as a result, when we go down, the depression on this part will be, the cavity on the bottom part will be high compared to the depression on the contact between the water and rock. As a result, when we see the depression, it will be something like this. It will have a narrow neck, and it will have a wider bottom portion. So this structure, what it is formed by the river, is called a pothole. So these potholes in later period, by the process, this will become wider and wider, and it may go deeper and deeper, and it is actually a process of a erosion process of a river, and that we call it as the first feature. It is a pothole. Okay, so that is first feature. Now the second feature which is produced by a river is a river valley. As you know that the rivers are flowing through the defined channels or the valleys. So if this is the surface, if you see here, this is the surface through which the river is flowing. At the point when there is a large amount of water by rainfall or an ice melting of ice, the water will start flowing through small channels. So these small channels we call it as gullies, rills or gullies, because these gullies are not permanent. This will come only during the time of high water influx, so it will be there for some period of time. Then after the monsoon, after the rainy season, these gullies will be not having water. But these processes of gully erosions will subsequently lead to a channel formation. Now what you are having here, these channels, small gullies which are formed, now it's are connected, and now these channels are formed. So this kind of channels will produce a streams, and these well defined streams flowing through a depression, we call it as a valley. So all our rivers which are flowing through these valleys in a definite channel. So here if you see, this is a valley in a bedrock channel. Okay, and these valleys will always have the different processes. Number one, the process is the downward cutting. So the valley will be more deeper and deeper as the time goes on. Okay, so this we call it as the deepening of the valley. Same time, there would be more number of gullies it will be forming, and this will be increasing the length of the channels or the valleys. So that process we call it as the valley lengthening. At the same time, this valley which is forming now, right now the water is flowing on this valley, this will increase the width also. So that process will also happening. That let us take an example of this river system, correct? So this is the same river what we have discussed yesterday. Now where is the valley on this river? The valley is, if you see on the bedrock part, the river which is flowing through the valley here. So if I take a cross section across this, so we can easily see where is the valley. So the water is flowing through here. So this is the valley through which the water flows, correct? If you come into the lower reaches where the floodplains are there, I'm little bit extending it towards the hard rock or the high terrain so that you will be able to understand the topography of this region. See, where is our valley? Our valley where the water flows is here. So the water channel is still smaller. Now I'm exactly on the water channel. The cross what you are seeing here, it is here, but the valley is wider. Okay, and it comes down to the more wider, then it comes down to the high terrains, high regions. Okay, so this way the channel. So this part, there are, what are the actions which are happening? The depth of the valley increasing by the flow of water, the width of the valley increasing, and if you go into this particular part where the valley is, the water is contributing. Okay, so here if you see, there is a small stream, this joining, and if you see the stream will be somewhere, it will be increasing its length also. And as a whole, the drainage basin, what you discussed in the last lecture, the drainage basin is where the water will be collecting by a river. So that process we call it as a drainage basin. Now for this particular river, if I see, there are two rivers. One we can see here, this is Narmada river. If you are able to see the cursor which is moving, this is the Narmada river and this is the Tapi river. Where is the drainage divide? The drainage divide is the hills what we are seeing here. So if I zoom the hill here and make a 3D view of that, you are able to see there are two rivers. Okay, so one river which is Narmada on the left hand side and Tapi on the right hand side. Narmada is now flowing through the hard rock and Tapi is now flowing through the alluvium. The hard rocks are much higher. So there would be small channels which will be developing on this this area, and it may come into one point of time, this upward cutting of this Tapi tributary will reach here. Because of the large amount of height difference between Narmada channel and the Tapi channel, the flow of water from some tributary may took towards the Tapi. So this process we call it as a river capturing. Simple process. One channel from Tapi, there is a channel that we can see. This channel is now extending its length. Now it's extended the length up to the top of the hill. Now there were another channel which was flowing towards Narmada, but what happened, this both the erosion processes mixed together, and a result, if I show you in the presentation what it will happen, there are one river which is flowing here, another river which is flowing here. There is a tributary. Tributary means a small stream of this river which is cutting this hill. Okay, now it reaches here, and there is another tributary which is cutting this hill. Now what happens, this hill, it cuts up to here. Now this hill cuts up to here. Now this, both of the cutting of the river joins together, and the water from that one river either flow on this way or this may flow on other side. So either of this will happen. Now these are two directions will change. Now water from this river or this channel will flow completely to this river. This process we call it as a river capturing. So this kind of things are also possible in the system, and this is not a very simple process as the way I am explaining. This also related to the changes in the topography, tectonic activities, shifting and slitting. So that is the process of river valley. Now the next is the river valleys. There are two types of river valleys, and gorges and canyons. Canyons are large, deep river valleys which are having a specific type of river valley which are having a horizontally stratified sedimentary rocks or the rock types. So this we see these all rock types are horizontal, perfectly horizontal rock types. So this we call it as a canyon, and the gorge is a gorge, and both are same, but canyons is a special type of that where the rocks are horizontal. This is a gorge. It's a large steep eroded valleys produced by a river. Now another erosional feature, what we call it as a waterfall. Waterfall is also a erosional feature. For example, if you see here, now the river is flowing on the surface, and the river is flowing through the surface of two different layers. This is one layer that is called S, that is limestone. Another layer is called shale, and below that there is another layer that is again shale. Now, when water flows through these three different varieties of rocks, water will have different action on these different rocks. For example, this will be slightly more resistant, or more erosion processes are acting on one kind of rocks. As a result, what happened? There would be a differential erosion process. So the water which was flowing on this part was completely removed very quickly. So as a result, the surface now becomes something like this. So there would be a change in the height. Okay, this much change in the height. So water will start flowing in a into this height difference. So this we call it as a waterfall, and waterfall is also another process or another landform produced by the water or running water. There are a number of reasons. One process is the difference in the property of rock, and there are other reasons. There may be some kind of structural features. We'll study it in later phase. There may be a fracture, and this block has moved down. So now the surface is something like this. So here it will produce a waterfall again. So that kind of different processes are again possible in the case of a river system. So this is the fourth feature. Then last one, it is a stream terrace. Stream terrace is again a erosional feature. If you see here, this large part of the river, we call it as the river valley. But where is the river now? River is now flowing here. And what is this step-like things? This step-like things, what you are seeing here, T1 and T2, we call it as terraces. So terraces are produced by the erosion activity of the river. If you remember my last lecture where I have said that river will be shifting within this valley. If the valley is in alluvial plain, it will be major shifting, and if it is not in alluvial plain, if it is in a gorges or in the hard rock terrain, then the lift shift would be limited, but still the downward cutting will produce some kind of terraces. But here I'll show you another. For example, I'm taking the same example. Here this is our Narmada river. So Narmada river, what I'm going to do is that I'm going to take a cross section across this river. So here this is the cross section of Narmada. Let me take it perfectly on this plane, alluvial plain only. Okay, now if you see here, what you are able to see, this is a elevation difference. See, the elevation here is 20 meter and here it is 30 meters. So there is a 10 meter elevation difference in this part. Okay, but here the elevation is 10 meter almost flat, and where the water flows here. Contrasting with that, in the opposite part, if you see, there would be another. So these terraces here are getting terrace 1 here, and T1 here, and terrace 2 here. But here we are getting only one terrace. We are not getting the perfect signature of the this contemporary terrace. But that we will get in other part. For example, if I make a cross section here. Now you see the cross section, what you are able to see. We are able to see the Narmada channel. On the channel, this is an island, and here we have one terrace and we have another terrace here. And we have another terrace here comparatively higher than this, and we have another terrace here at a 20 meter elevation. So this terrace is more sloping because of the sediments which are contributing from this, and there are a number of other rivers also. So that they are cutting. But if you generally take this height, that becomes somewhere around 20 meter, and there is one more level on the right hand side. So this kind of processes that we are producing, what we call it as the terrace. And if you remember my first lecture where I have discussed about the Wasat bridge, where I have discussed that the buildings which was created and all that buildings they have created in the first terrace. That is what the trouble what they have done. That is the terrace one, that is the recent terrace, and the bridge where we are right now connecting that bridge, that is in the terrace 2, and that is very occasionally what we can reach up to terrace 2, or it is only possible in a very high floodings, and in the terrace 1 it is a very normal, very active part of the river. Correct. So that is the terrace. Now erosion processes we have seen. Erosion features produced by the river what we have seen. Now the next is the transportation process. Transportation process means when the river erodes something from the surface, now that material needs to be transported to the lower part of the river or the downstream side of the river. So that transportation processes have done by the river in 3 categories. That 3 categories are called the bed load, the suspended load, and the dissolved load. What is these 3 types? Bed load is means the river is plucking the large sediment, but it is not able to pick it from the surface. As a result, what it will do, it will either roll the sediment or the rock or small rock sizes or the gravel size particles, or it will slide the material, something like this. Okay, so it will either roll the material or it will either plug the material, slide the material, or it will jump if it is something able to the jump. So these 3 processes will be happening, either rolling or sliding or jumping. So this jumping process we call it as a saltation process. So these 3 are the main processes by which the river transport material. What you see here is the rock surface, and this is the water level. We are seeing a cross-sectional view of the river. So these processes, 3 processes what we do, this is called a bed load. It is done by rolling, sliding, and saltation process. Then the rivers will transport some material in suspension. These smaller materials what you are seeing here, these all are the suspended materials. Okay, that remains in suspension. That the size of the particles are small, so the river is capable to get it from away from the surface, to pick it from the surface. So it pick the things, and it will transport within the water, which will be transported as a suspended load. And the third one, it is the dissolved load. The dissolved load is what we may not be able to see the grains, but when we filter the water, we will be able to see the materials which are dissolved in the water. So these are the 3 different ways the sediments transport by the river. Now erosion and the features and the transportation, what are the different mode? But and the third activity is the deposition. Transportation doesn't make any features, it rather transport one material from one part to another part, but the deposition of the river which makes different features. Okay, deposition means all these materials which are transporting either in suspension or in bed load or in dissolved load, it will be depositing somewhere in the course of river system. Ultimately everything will be depositing to the sea, but in between there are so many other areas where it will be depositing. For example, if in a flood, if you see that the flood water coming into our regions after the flood retreat, if you see there would be a thick layer of sediment depositing, what we clean usually after the flood. So that is a sediment deposited by the river. So that materials mostly remains in suspension. This bed load materials will not come. That materials comes with mostly on suspension material. That is what the fine clay materials what we get in the get after the flood. Now deposition of a river which starts from the headland region to midland region to the mouth region. So this deposition will be happening in different regions. One we call it as an alluvial fans. So alluvial fans are cone-shaped accumulation of stream deposited in the base of the hill, and floodplains is in the middle region where the sediments depositing on either banks of the river. So there are 3 different varieties of floodplains, either convex, conveyed, and there is one feature we call it as a natural levee. This is a comparatively elevated surface towards the river. Then there is deposits within the channel that we call it as basically bars. sandbars, or sometimes it is a point bar, sometimes it is a channel bar, or sometimes it is a island. Or last one, it is the delta, which is depositing at the mouth of the river. Okay, so we are going to see one by one. First one, we are going to see an alluvial fan. So alluvial fan is something like this. Okay, so this is the hilly terrain, and if you want to see the hilly terrain here, we are right now in the Himalayan terrain, where the Himalayan, because the other part in Gujarat and other part, we are not able to see the alluvial fans right now, because these all alluvial fans are now below the floodplain. So the floodplain sediments, the loose sediments, or the overbank deposits, or the flooding deposits, which are all covering the sediments, so all these things are below the surface, we are not able to see. But in the Himalayan rivers, if you go, we are able to see these alluvial fans. What you are seeing here, this is Indus River flowing on the Leh. Leh is a well-known tourist place, so I hope you all understand where the location of Leh is. If you see on our Indian map, okay, so this is the map of our India, and we are here somewhere in the Himalayan terrain and the Leh Valley. Okay, so Leh Valley, if you see these are all sediments which are, okay, these are all the sediments or the water streams which are flowing from the hilly terrain, and when it flows to the hilly terrain and after it ending here, so it is depositing most of its sediments which are transported by the river at the foothill. This is the part where the valley starts. So this is almost a plain surface, and when it reaches the plain surface, the river is not capable to carry all these materials. As a result, what will happen? The river will deposit all these materials in the front part of the hilly terrain. So see, all these deposits are depositing, and as a result, this is the river which flows, but these surfaces are formed by a alluvial fan. So we sometimes call different terminologies for this. We call it as if the slope activity is more, we call it as a colluvial fans. If it is river activity is more, and we call it as an alluvial fan. So a number of different terminologies are there, but ultimately the process is the large amount of sediments which are transported by the river are depositing in the foothill. See this part, if you see, this is a very good alluvial fan, and I hope you are able to appreciate the different generations of alluvial fans also. Now you see this river which was flowing here, now it started flowing on this panel. So it is like the river which is waving from one end to another end. The movement of river is there. Okay, river must be flowing somewhere on this part. Now it has started flowing on this part. So number of areas where it is changing the path. So this process, this is called a alluvial fan. We can see that in the Leh Valley, there are number of alluvial fans are there. All these small tributaries which are contributing the river, everywhere you are able to see the alluvial fans. Some of these alluvial fans are already stabilized. Stabilized means there is a growth of plant. See, this is a very fertile land, so people started using it for some kind of cultivations, or it is a normal grassland or something like that. Okay, so this processes are, so this would be an older one, and these are all active alluvial fans. So this is one feature. Second one, it is a floodplain. To see the floodplain, let us go to our area, Narmada only, where we have already seen. So that is our floodplain. See, this is the area where the Narmada river is flowing out of this Kevadia colony, and all this part we call it as a floodplain. Floodplain means is relatively flat land. And if you see Narmada, then there is another river. This is our Mahi river. Then we have Sabarmati. So all these rivers together, it makes a floodplain. And if you see the elevation or the cross section of all these rivers, we can see these are almost flat terrain. See, the variation of the height is from 40 meters to around 30 meters. All this area, this is around 83 kilometers what you are looking at, and there is only a 10 meter difference in the height. So that means this is almost and one river comes here, another river comes here, and third river comes here. So this almost flat land which is produced by all these rivers together, we call it as a floodplain, and within this floodplain all these rivers are changing its path also. If you want to see how it changes the path, so this is another river. This is in Bihar, Koshi River. You must have heard about the Koshi River, and few years back during a high flooding season, the Koshi River have completely shifted its channel. So this is the scenario of Koshi River in 1984. It was something like this. It was flowing something like this. And in 2018, if you see, you can see that there is a lot of changes in the path of the river. See, look at here. This is one point bar, 1984, and this is now detached, and there is a new channel which formed. See, the river is flowing only single channel. Now 1884, if you see that it is flowing on different channels. So this kind of lot of changes are actually happening in the river. So if you see the series of changes what it is happening on this river, just look at the stream. So how much changes are there? There are so many areas where changes are happening in the river system in a time series base. Okay, so this is around 40 years of story what I am talking about. Now we can imagine the life of the Earth's surface. It is 4.5 billion years, and large to so many millions of billions of years, the surface processes are changing, and this is actually creating lot of topographical changes in the surface of the Earth. Now another important feature, and I talked about this we have already discussed. So this is the river, and the area where adjacent to the river deposit the sediments during its flooding. We call it as a floodplain. And natural levees are slightly elevated points on the floodplain towards the water. So this is a river channel. If you see, this is a river channel, and this surface, what it is slightly elevated than the nearby floodplain. I'll tell you why is this, because when the river flowing through and river started overflowing the banks, what happens here in this part, there would be a large amount of sediments in suspension or in saltation. That sediments will be there. So river will not be able to flow it with that same energy what it is having in the channel at this part. So as a result, what happens, it will deposit the sediments towards very closer to the channel, the river channel, existing channel. So as a result, that becomes slightly elevated, and it will go away from here. The size of the sediments and the amount of the sediments decreases. So as a result, it will become gently sloping away from the streams, away from the channel. So this part we call it as a natural levee. So this natural levee is, there are artificial levees also, what we prepare when you study the irrigation. You will study the levee that would be constructing in the canals. When you construct a canal, the banks of the canal we slightly elevate from the nearby area so that the water will not overflow immediately. So that we call it as artificial levee. So we'll see the designs of that in the later. Now one feature what we are to discuss is the deposits within the channel. Deposits which are happening within the channel, we call it as bar deposits. Okay, so bar deposits are the amount of sediments which are depositing within a river. For example, if you see all rivers, any river if you take, you will be able to see that. If you see that this is a bend of the river, okay, and this river is bending here. And yesterday, if you remember that the flow velocity should be maximum towards this end where the river would be cutting, and the flow velocity would be minimum on the towards the curvature. As a result, what happens, the river will start depositing on this bends. So the river which is depositing on this curve, inner portion of the curve, this deposits, we call it as a point bar. We call it as a point bar. And if these deposits are forming sides of the river in a straight line, we call it as a lateral bars. Okay, sometimes the lateral bars would be having an alignment which is perpendicular to the direction of the flow. We call it as a transverse bars, and the longitudinal bars, something like that. And if the sediments are depositing within the channel, we call it as a channel bar, and if it is stabilizing, we call it as a island. Okay, so islands are formed, channel bars are formed, point bars are formed. So now this was formed as a point bar, now this was now converting into a land. Okay, so here we can see there is a deposit. channel bar deposition is here. Here it is a point bar deposition. So that kind of deposits are also happening in the case of a river system. And last one, which is towards the mouth, the river will be depositing the delta. So delta is all the sediments. If it is not able to deposit any of the sediments in the alluvial fans, or if it is not possible to deposit the sediments in the channel, or if it is not possible to deposit the sediments over bank, then ultimately this will be depositing in the delta. Okay, so we have discussed about the deposits in the foothills, deposits within the channel, deposits in the overbank and the floodplain. Now, one last thing about the river, that is oxbow lake. Second last thing, river meandering and oxbow lakes. These are the results of river erosion process. This is a feature produced by the river. River meandering is nothing but when the velocity decreases from the slope decreases, the river will not be able to flow in a straight line. As a result, the river will take a curved path. So this curved path produced by the river, we call it as a river meandering. So the same single river, if you see here, Narmada river I am looking at. So this Narmada river in the upstream part, it is flowing through a straight channel, and when it comes to the lower portion where it is, this is a floodplain. Okay, when it comes to a elevation difference, and as a result, what happens? The river now started flowing into an almost flat land, and it is taking these curved paths. Okay, these curvatures, these are taking. These curvatures which are taken by the river, we call it as a meandering. So this meandering, sometimes what happens, this meandering or the curvature of this meanders increases. For example, the same Narmada river, I am looking at Madhya Pradesh, in somewhere around Hoshangabad. Okay, so here if you see, this is a meander, same meander, okay, meandering river. Now this meandering river is flowing here, and if you look at this part, what you see here, you can see a small channel here. Okay, so it is what a older channel. So once upon a time, the river was flowing something like this, and it started cutting, and as a result of continuous cutting, what happens after some time, the river started flowing through this channel. So this portion of the channel which left out, so this meandering which left out by the river sometimes remains some amount of water, stores some amount of water. So this water which storing in this kind of left out channels, we call it as a oxbow lake. But we call it as a oxbow lake. So oxbow lake is a channel which produced by, or a lake which is produced by the meander cutoff. Okay, so earlier the river was something like this, flowing through a curve or a meander, and this meander neck which reduces its width slowly. It took so many years, and once upon a time, in a case of a major flood or something, the meander neck will completely cut and it started flowing straight. As a result, what happens? The river started flowing straight, so it left a curved path, and that curved path we call it as a oxbow lake. So that is again a river feature. Basically, we cannot say it as a depositionate feature. It's a river feature, and this meandering and oxbow lakes, I'm putting it here in the river depositional feature, but it is a river, large scale river morphological feature.